Hi guys, sorry this is taking me a little bit to load because I was having problems with my phone, so I'm doing it a little bit different this time. So I took problem 3. The reason I took problem 3 is because I'm going into animal health and behavior, and at some point I'm going to have to do some of these percentages on what an animal digests and how long it stays in their system. So my problem is a dog takes 400 milligrams of Rimadyl. Each hour, the amount of Rimadyl in the dog system decreases by about 29%. How much Rimadyl is left in the dog system after 6 hours? So what we're going to do with this formula is exponential decrease or decay. So we have, and the formula for that is y equals a times 1 minus b to the x power, to the power of x. So if we look at this, we have 400 milligrams of Rimadyl in the dog system. So we're going to, y is what we're figuring for. So we're going to move 400 times 1 minus 0.29, or 100% minus 29% to the x power. And that's going to give us our totals per hour. So when we look at it this way, we have, we come down here, we do hour and a percent of Rimadyl left in the system. So at 0 hours, as soon as the dog takes it, it still has 100% of the Rimadyl left in its system. Now, 1 hour, we can take our formula here and we're going to minus that 29, which gives us 0.71 or 71%. So we plug that into our formula. So we have 400 times 71%, or 0.71, and that equals 284 milligrams left in a system. So when we come down here, we've already figured out the equation on the inside, which is the 1 minus the 0.29. So all we have to do now is multiply the milligrams times what we've come up with our percentage decrease. So 400 milligrams times 0.71 to the second power for 2 hours equals 201.64 milligrams. So we go all the way down and we come to the final for 6 hours. We've got 400 times 0.71 to the sixth power equals a total of 51.24 milligrams left in the dog system. So if we turn that into a logarithmic function, which logarithmic functions are good to help us manipulate smaller numbers when we're working with larger numbers. So if we have this in logarithmic function, the actual formula for it is y equals log v times x. Okay, so basically what that says is y equals the log of x with a base of b. So our y is actually what our power is. All this is saying is b to the y power. So if we looked at it differently, if we looked at it x equals 2 to the power of y, if we had a base of 2. But in this case, we have a base of 6, which is 6 hours. 6 to the power of y. So in that logarithmic function, we can flip these around. We can flip this exponential formula over to equal y equals the log. Remember, when you flip that x and that y, you want to put a log in there. The base, which our base in this formula is 0.71 of x. So y is 6 because it's 0.71 to the 6th power. So 6 equals log with a base of 0.71. So the log of x with a base of 0.71 equals 6. And all that's saying is 0.71 to the 6th power. Okay, thanks guys.